Well, first of all, I want to say thank you for inviting me here to be a part of Alpha Industries. It's always a pleasure, and I've respected the company for a long time and the equipment you all develop. So, yeah, where's my story? Well, my story begins a long time ago, I suspect you can say now, but aviation was always part of my family. My dad was one of the first air traffic controllers, and so when I was a young boy in West Texas, I grew up watching airplanes take off from the airfield out near where we lived, and sat in the tower and watched the airplanes take off and land. And so that's where I developed my first passion for aviation. But it really expanded in the 1960s when the space program to get started. In fact, if you look back over here on this piece of equipment here from Alpha Industries, you can see all of the Apollo patches that came for the moon landings that began in 1969. But of course, as everybody should know, that's not when our space program started with Apollo. It began before that. So you had the Mercury and Gemini programs. Well, I was a ready watcher of those launches, and I thought to myself, well, that's what I want to do someday, is become an astronaut, because it kind of had everything that you want: cool spacesuits, a little bit of danger, a little bit of excitement. They were always on television. I thought that's what I wanted to do. So I started out in high school just being a normal high school person, actually, not really focused much on becoming an astronaut. But then when I went to my undergraduate work at Texas Tech University and was getting my degree and about to graduate, I sat down and really asked myself, what did I want to do? And I said, I've always had the dream of becoming an astronaut, but I made that one decision that really led me to it. I said I didn't want to be an astronaut. I will become an astronaut. And so I made the right decision to go speak to the only person at Texas Tech University who is actually focused on aviation, and that was the Air Force recruiter in the ROTC. So the next thing you know, I'm taking a physical at the local Air Force base, and he says, I'm going to get you a pilot slot, and I knew right then I was on my way. So the next few years found me doing graduate work at the University of Texas in aerospace engineering, and once I finished that, I went right into the Air Force and started flying aircraft, and then I laid down that plan to become an astronaut, which was to fly high-performance aircraft, become a test pilot, and then eventually apply to NASA and get selected. And all of that came kind of true. So I got to fly my high-performance aircraft. I got to go to test pilot school, and then the first time I applied to NASA, NASA said, no, thank you. So that was my first really big introduction to, you don't always get to do at first what you want to do, but I was persistent and continued to develop my skill sets. And then in 1996, I applied again, and that was the year that NASA brought in its largest group of astronauts ever. And I happened to be part of that class of 10 pilots and about 35 mission specialists. So there were 10 pilots, and we all were picked up in the group of 16. And so 16 group of the class of the 16th class of astronauts in 1996. And so for the next few years then, I trained to become a Space Shuttle astronaut pilot, specifically to pilot the Space Shuttle. And in 2002, I had the opportunity to fly on the Space Shuttle Endeavour on mission STS, so Space Transportation System 111. And I got to bring up the expedition crew number 5 and bring home the expedition crew number 4. These are the ones that are living on the space station. So there's 3 to a expedition crew back then. So I brought home 4, brought up 5. And we did that successfully in June of 2002, and then started doing the other work that crews do in between flights. When I got the call just about a month and a half later after landing, did I want to go fly again? And of course I did. And so I flew on STS-113 just a few months later, and the interesting part is I got to bring home Expedition 5. And so that crew of Peggy Whitson, Valery Korsun, and Sergei Treshev were pretty special to me, especially Peggy Whitson. If anybody knows Peggy, she's a special lady. And so I had my 2 flights, and then one of those events that happens in everyone's life every so often that has a major turn in what you do occurred to me and to NASA at that time. In the start of 2003, on February 3rd, we lost the Space Shuttle Columbia, and so that kind of put before me a decision: do I continue to stay at NASA? I'd flown 2 missions, had been there 7 years, and when I looked at that, I found that I was actually missing the military. My peers in the Air Force, and Operation Iraqi Freedom was starting in March of 2003, and that was to, of course, depose Saddam Hussein. And I knew that I could not fly combat, but I felt there was a way I could support those who did, so I chose to go back Air Force, which then brought me back from overseas, back to the Pentagon, and now a few years later, here I am, sitting here discussing space with everyone here. So that's kind of a semi-long wrap-up of what I've done, but I'm just happy to be here, able to talk to everyone. So there is the training and the selection to be an astronaut that I think is descriptive of how I became one and trained. But that's really changing rapidly now for the new astronauts that are being selected. So previously, all of the vehicles, as you can imagine, with rockets and the Space Shuttle, and actually all spacecraft are experimental at first, but these were vehicles that we really didn't understand completely very well. As you can imagine, the Space Shuttle was designed by many folks that were still using slide rules in the 70s and so forth. And so it was known that to actually fly the vehicle, NASA wanted to rely upon test pilots, which I fit extremely well, and as did all of the crew. And then the mission specialists, who may not have been pilots but had specialties in certain things that NASA needed, might have been, in medical or research of the Earth or things of that nature. They fleshed out the crews that were on the Space Shuttle. So when I got picked up at NASA, my training specifically as a pilot was focused on, can I help fly this vehicle? In other words, can I be a part of the mission that flies the Space Shuttle and manages the system safely to get us up on orbit, do the operations on orbit, and then come back and land? And when you think about the Space Shuttle, in a sense, we've got a winged vehicle right here. We're taking basically the equivalent of a vehicle that's going to launch from the Earth and become a rocket, then go into orbit, and then become an orbiting spacecraft. And then for return to Earth, it has to become a reentry vehicle. So we slow the vehicle down and then re-enter the Earth's atmosphere. And now the Space Shuttle becomes a high-speed reentry vehicle, and then finally a glider. And so that's a very, very complex system. So my entire time was spent specifically on making sure that we got this vehicle safely up and down. And then the rest of the crew focused on performing the mission on orbit. Well, that's changing now. If you saw the SpaceX mission with our first 2 astronauts, NASA astronauts, you saw the new future of spaceflight. And what do I mean by that? Computers and the ability to, have autonomous operations. In other words, the vehicle itself is monitoring everything. It's not specifically done by people on the ground. The vehicle itself allows a lot more autonomy, and many of the actions, such as ascent and rendezvous and things of this nature, will be performed by the vehicle itself and managed by the crew. So what you're starting to see is less a separation between the pilots and the astronauts that do the flying and then the scientists and so forth. So now you can start to see that you become, in a sense, mission managers in a way. So it's the same way cars are going. In other words, you're going to drive your vehicle and do it so, do it in a safe manner. So that's the future going forward. But it all means the same thing for those that want to become astronauts. You've got to learn to become good in a wide variety of tasks. In other words, both understanding your vehicle, but you've got to be good at the other tasks that NASA brings you on to do, whether that's in science or engineering or whatever the case may be. So, well, that's actually, for the young kids, the coolest part is having your M&Ms at the end of a hard day's work when you sit down and you have your meal, and then at the end of it you break these apart, and then you spend time with your crew and you reminisce about all the good work that you did today, whether it was a spacewalk or deploying a satellite, or now on the space station, they're doing so many more things. But for us, it was building the space station. And so kind of the neat part was afterwards, enjoying the time with the crew and then having our meals. But looking out that window, of course, is probably the most spectacular thing you can do. From a position perspective, or from a person's feelings perspective in terms of their physical body, that the ability to be, in a sense, in a microgravity environment, as we call it, floating in space, is really a new environment, and it's got its pluses and minuses, but it is something special to experience and live in for a period of time. So I would say living in space is really neat, the microgravity, the floating in space, but then, of course, looking out at our beautiful Earth is probably the highlight of any space flight for anyone. So that's an excellent question. So you know that we have to protect ourselves here on Earth. So a lot of this equipment behind us from Alpha Industries right here, the jackets and so forth, are necessary because you and I can't handle temperature extremes beyond just a very narrow band, right? Less than 50 degrees, people get cold, and more than 80 degrees, they get pretty hot. So we have a very narrow band of temperatures and other things that make us comfortable. So I'm trying to point out that our bodies really are not meant to live in space per se, right? That's just not where we live, because the temperatures extremes there are significant. There's no oxygen per se other than what you either generate or bring with you. And so living in space is difficult and takes time to adapt. Well, that's all of your processes that make up your body per se. The process of just taking in food and digesting food, and then learning to sleep in space, and then learning to take care of yourself in space is a science in and of itself. So so you can start it as soon as you get on orbit. So for example, when you go into the microgravity, which I said was really a fun thing to do, and it is, you find that your spine decompresses because it's not under gravity. So now all of a sudden the spine elongates and your muscles are kind of pulled. They're no longer under that. They're under a different kind of tension. And so you start to feel the lower back pains, because now you're 2 inches taller than you were when you were on Earth. So that's the first thing you have to adapt to. And then your ability to know which way is up or down is thrown helter-skelter. So you and I right now, we stand upright. We use our eyes to know where the floor and the ceiling is, and then we have other parts of our body, such as the inner ear, that helps us know whether we're tilting left or right, forwards and backwards, and so forth. Well, in microgravity, that's all thrown out. You can't really tell what is up, what is down, and it takes a while for your body to say, okay, I'm in a new environment, but I can handle this. I may be talking to somebody, and they're floating in front of me, and they're upside down to me, but for that other person, I'm upside down to them too. And so it takes a while for your body to adapt to that. But it can. The bringing in of food is also, and the tasting of food changes also on orbit. And that's because the fluids that are in your lower part of your body, they float up into your upper abdomen. And so you start to have the open spaces that are within your face and throat filled with some of the fluid from your body. And that gives you the sensation of having a cold. If you look at images of astronauts on orbit, many times it looks as if their faces are a little puffy, and that's because they have those extra fluids. Well, that impacts, as I said, your ability to know whether you're up or down or left or right, but also your taste of smell. Your sense of smell and your taste are altered a bit. So that is another consideration. But the part, and this is where we're getting to it, the part that I disliked the least, of course, was, okay, I bring in all of this food and my body finally learns to digest it, but it still has to rid itself out. And so it's the waste control system that you have to learn to deal with on orbit. That's the hardest thing. And that's not just the mechanical device that you use, the toilet on orbit, but it's also just your body's abdomen having to learn how to push everything around without the use of gravity. So when I got extended on both my flights, I was happy as could be, except for one thing. I knew I had to stay on orbit for a few more days and, use the waste control system, which was not the best thing. And there's only one. And let me tell a side story that's kind of funny on that. When I had decided to become an astronaut in college, and I said, I'm going to be an astronaut, I went in and spoke to that Air Force colonel who was in charge of ROTC, and he said, son, how bad do you want to be an astronaut? And I said, sir, I want to fly the space shuttle so bad that I'd clean the toilets on the space shuttle if they'd let me, so long as I'm an astronaut. Well, guess what? So many years later, when I get selected to be an astronaut, and then you're the pilot, you're not the commander for the first or second flight. Guess what the job of the pilot is, since he's in charge of all the systems on orbit? Yes, sirree, the waste control system is under his responsibility. So I had to make sure that that thing operated and worked properly, and was a good place for everybody to go. And I took that very seriously because there's only one on orbit, and if it breaks, then no one's happy. Well, that question is really a timely and good question, because it's really marking the difference in how spaceflight was done previously till now. So, how are the SpaceX missions different from the Space Shuttle missions? Well, first of all, I would say that both missions use reusable parts of their vehicles, right? That's what SpaceX is known for, trying to make sure they reuse as much of the system that they have. But the Space Shuttle did that too. Let me bring up this picture right here, the Space Shuttle on my launch, which hopefully you can see. You can see the external tank, and then the white solid rocket boosters, and then the Space Shuttle right through there. Well, all of that except the external tank was reusable. The difference is that this vehicle itself has computers and software that fly the vehicle, but they're very simple machines. In other words, the memory size, the capability to perform calculations is very limited on the Space Shuttle. Now, if you move to the vehicles that we have now, computing and processing power and software itself are much more advanced, and as well as the concepts of using autonomous operations. And so now the vehicles nowadays are much more autonomous. So when I watched the first crew from the SpaceX, which, by the way, they had great visuals. The cameras were excellent then, as opposed to when we were flying. As they strapped in and they brought up the computer screens for the two astronauts to interface with the spacecraft, the SpaceX launch vehicle, the Dragon space capsule, it became really apparent to me that the way that they operated with the vehicle was through a computer interface, right? Just like we do now with our computer screens, if you have touch screens. So there no longer is, as there was in the Space Shuttle, mechanical switches like you would have had in an older car, that you had to throw a switch, and when you threw a switch, an electrical signal was sent down somewhere and a valve opened, or whatever the case. So that's not the case nowadays. It's all computer interface in between, and then all that software allows for autonomous operations. And that's a good thing in some ways, I think, because it allows the crew to focus on critical parts of the vehicle. You have much that may be necessary, and they have much better information. We in the Space Shuttle had lots of information come to it, but it was all in numbers. So we had computer screens that were older, and the numbers would come up, and I had to interpret numbers. And this number might be, well, what's the pressure in this fuel tank? And then the second one behind it was a redundant sensor that said, okay, this is the pressure in that fuel tank. And so I had to look at this reams of data and interpret that. But now it's much easier to use. It's much like the applications that we use on our computers and our cell phones. So that's one of the major differences. And that also speaks, as I said earlier, about the training that astronauts are going to go through now. No longer do you have to have test pilots per se that know how to handle the situation and fly the vehicle, because there's this box of software that lies in there that's flying the vehicle most of the time, to including a rendezvous. And now you become almost a mission manager rather than the pilot that's flying it. Now, we did not fly the Space Shuttle on ascent, but we did fly the Space Shuttle coming in on landing. And as you know, the Space Shuttle, as I said, was a glider, and as you came in, the landing gear had to come down. And so you actually flew and landed it like an airliner, although we didn't come in at the same speeds. We were faster, and we didn't come in at a low angle. We actually came down pointed at 20 degrees nose down. But as you notice, we're now back. The Dragon space capsule is landing in the ocean because it's coming underneath a parachute, so the crew doesn't fly the vehicle. So we're moving back to that, and part of that is because, you know, we found that this is really on the edge of that which is very difficult to do. There's a lot that can happen if you fly a vehicle such as this, and it's a winged vehicle coming back through the Earth's atmosphere at those high speeds. So I think those are the big changes between space flight that's going to occur now and space flight that has occurred previously. We have everything that's needed to make the next big leap in spaceflight. We have the technology, we understand that. The question is what are we going to do? In other words, are we going to go back to the moon and set up a location on orbit around the moon or on the surface of the moon itself that's going to be our next, I guess, place to learn to live in space and to explore and to develop the skill sets that are going to allow us to go even further into space? Or are we going to go to Mars directly? Right now, NASA's planning to go back to the moon, but that's always been a big decision amongst many of those who are always trying to do space technology. Do we go to the moon or Mars next and things or whatever? Whatever the decision is, I know that trying to have the human survive in space is going to probably be one of the most important aspects of spaceflight that we're going to have to better understand in the future. As I talked about earlier, the human body is really just not meant to live in space. We can adapt to live in space, and the body learns how to live in space, but our bodies itself really aren't protected from the extremes that are in space, the extreme temperatures and cold, and the one that I think is the most difficult to overcome, and that's deep space radiation. So for those flights that are going to go to the moon and spend long periods of time there, or to Mars, which is going to take whatever, depending upon the route you take, it's going to take months to get there, and then you're going to spend time on Mars and then months back, so we're talking years in total. The crew are going to be exposed to deep space radiation, and that's going to be a problem we're going to have to solve. So that, to me, is the physiological aspect that's going to be the next game changer, is how can we learn to live in space and protect ourselves and mentally keep ourselves sharp for that period of time. If you can imagine a crew being, placed in a small confine for the long space trip, and then spending time there away from their families and so forth, that's a mental adjustment that they have to go through and that they have to be prepared for. But at the same time, they have to be able to handle emergencies and whatever may happen during their long trip. And so, being able to maintain mentally positive and sharp throughout the entire space flight is going to be difficult. On the technology side, we already understand the technology for the rockets. We can get to where we need to go. We can keep ourselves alive in this spacecraft. But I think the next game changers are going to be those things that are going to allow us to live on the surface of the moon. So those are the ones that are being developed now, but really haven't been tested, and that is, how can we produce the fuel that we're going to need for the return flight on the surface? How can we produce the foods that we need? How can we produce the waters that are going to keep us alive? So in other words, how can we live for an extended period of time on a different planetary surface than the Earth, or in low Earth orbit, which is where the space station is now. So those technologies are going to be the ones that are going to be the next game changers. How can we mentally keep ourselves sharp and protect ourselves from the rigors of space, and then how can we keep ourselves alive by developing the ability to build up the provisions that allow us to eat and drink and generate the fuels necessary and the energy for the electrical needs and so forth for being on the surface of the moon or Mars. One word that covers how I feel every time I looked at the Earth from space, and that word is majestic. When you look at, and it is true, when you look at space and it's pure black, the sun is bright, it's hard to look at because it's so bright, and the moon is crisp and clear, and so you can really see the moon, and the stars are still there. They don't look any different other than they really don't pulsate or twinkle. But when your eyes capture the curvature of the Earth and the colors and the various events that are occurring on the Earth, the thunderstorms and or the large weather events like hurricanes, or you can see sandstorms and you can see ocean currents, when that all's come together and you can look at that from that view from up looking down, it's overwhelming. And in my mind, the one word that captured that was majestic. I think there are many things that we humans on Earth do that take us away from our families, and so I don't want to presuppose that that astronauts are the only ones. And the astronauts, though, do have to consider that they're separated from families for a long time, but then so are many other folks, our military, our firefighters at times, and then just folks that work for the government or for companies or people that work in oil exploration and things of this nature. But there is one difference. All of those have a pathway to get home, right? They can get on an aircraft and come back or whatever the case is. When you're on orbit, there isn't that easy, quick path home, and especially if you're going on a long duration space flight to, for example, the moon or even deeper into Mars, that time frame changes into months or years. And so the concept of being away from family takes on a different aspect, and most of all, I think it's a concern of how can I care for my family while I'm away. So it's one that all of the astronauts take with them, and it's why we prepare so much for those types of space flights in the very unique aspect of we can't get home if necessary. Yeah, so there are astronauts and there are the astronomers and the cosmologists that, that study the universe. So I always thought of myself as your simple pilot that flew the space shuttle, and I was the astronaut to get the vehicle up and down safely. And my understanding of deep space, especially, well, let's see if I can find that picture I had here just a second ago. Well, I'll get that in just a second. I had one. Here it is. So when you look at the Hubble telescope right through here, somewhere in this image taken by the Hubble telescope is a black hole, I suspect, and we may or may not have that in there. But on the other side of a black hole, from my perspective, is that part of space that is so hard to grasp because of the size, the distances of space, the energy that's evolved or that is inherent in all parts of the universe, and it was just beyond my capability to really know what's on the other side of a black hole. It's something that it speaks to the grandeur of the universe, I think. And I know that there are those smart people that are studying that and that have a better understanding of it. And I hope to learn along with you what's on the other side of that black hole someday myself. Oh, the best part of the ISS? That's a great question. There are some very beautiful windows that allow you to look down on the Earth in the cupola. So that's like having a bay window in your house, in the kitchen, where you're looking out in your backyard and you're seeing the beautiful flowers that you've planted, or the trees. Well, the cupola allows the astronauts, once they take off the covers, to look down on the beautiful Earth with this great view. And so that's probably the best part of the International Space Station. But that's from a perspective of, what does it afford us to do, which is look down on the Earth, which, as I described, the Earth is majestic. Other than that, the space station is a wonderfully constructed engineering marvel. And I applaud all of America's, all of ours, your parents, your grandparents, anybody that was associated with NASA, and their ability to have designed this International Space Station and constructed it so that the first time we put all of the pieces together on orbit, they worked, right? And it's solid and it's strong, and it's very representative of the engineering of the United States and our international partners. And so from that perspective, that's what's best. It's a wonderful place to learn how to live and work in space. So do I ever think that we'll have to leave the Earth? Well, I certainly hope not, because I think it's beautiful here, and my time on orbit just reinforced that. I mean, I can't imagine getting away from the mountains in the western part of the United States, or seeing the sunrise on the East Coast, or looking at the ocean in San Diego. I hope that we never have to leave the Earth. Of course, there's always that possibility, but we don't have that technology yet. We're just now at the beginning of learning the skill sets that allow us to actually leave the Earth's surface and live somewhere else, but that's a long time into the future. I like to think that we'll be here for a long time. So how did I feel the first time I went into space? So that's in a sense a multi-faceted question. So as I mentioned earlier, body has to learn to adapt. So the first time I got into space, although I was a test pilot and I was used to flying high-performance aircraft, I still felt as if all of a sudden my gyros in my head, the part that tells me whether I'm upside down or sideways, had gone uncaged. And so here I was, as still as I could be, and I felt that I was tumbling in space because my body wasn't used to it. But as I said, the body learns to adapt pretty well. So that part was something that I could learn. In other words, my body learned to adapt and live in space. But then you go to the other aspect of it. How did I feel my first time in space? Well, there's the, oh my gosh, I'm here. All of the hard work that I'd done, all those years of training and learning and studying and so forth, put me in this position where I could succeed, and here I am. But that was just momentary. Then it was on to get the job done and make sure that I was doing the right thing and taking care of all of my, my chores and duties. And so I felt as if I had been given a great responsibility, and it was my job to do it the best that I could. Let me tell you the first image I had of the Earth, though, on ascent the first time, which kind of, in a sense, covers everything I just tried to describe. So the Space Shuttle on ascent, and it would still be on the external tank right through here, it lifts off, as you can see in this picture right through here, and it starts to fly this curved path because it's got to head into orbit. And so it's trying to aim for that trajectory. So the Space Shuttle ascent, it's hitting that trajectory, and at one point it rolls from heads down to heads up as it gets into space. And when it did that, that's about 3/4 of the way through the 8.5-minute ascent into space. And I could look out my window. I took the opportunity to come off my duties to make sure that the engines were looking good, and I looked out my window for the first time, and I saw black, 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 and then this beautiful blue thing rolled into view, and that was the Atlantic Ocean. the curvature of the Earth. And that was such a stunning sight that it was basically just printed into my mind at that time. And so that was the beginning of how I felt in space, which is what a special place this is, what a special time, what a great opportunity to be part of our nation's space program and to be part of this special crew to do these what I thought were very special things to build the space station. Yeah, so the second time for me was almost even more special, because the first time you don't exactly know what to suspect, and you're so focused on doing the right job that you're intently focused on performing everything like you're supposed to do. On the second time, I knew what to expect, and time kind of, in a sense, slowed down, and I could actually witness going past the launch tower, and then I could feel the space shuttle roll, and I just had a much better awareness. So I enjoyed the second mission more. It was almost as if you'd gotten the nervousness of your first flight out of the way, and you knew what to expect, and you could enjoy it. So I could do everything just as I was doing the first time. And in fact, on the second launch, we had more small situations develop on ascent that required my attention. Not emergencies, but anomalies in the space shuttle as we were going up. And I handled them with ease along with our crew. And I just realized that I had fallen right into that groove that everybody has their interest in life, whether it's a professional sports player, a musician, or an actor or whatever. I just felt all of a sudden that I was connected with the vehicle and my crew, and everything was clicking just right. And so the second launch to me was my favorite of those two.